The goal for today's lesson is to compare numbers written in scientific notation. Really, there's nothing new that we're covering in this lesson that we haven't already discussed or worked on before, just reinforcing some of the things previously learned. So, a couple of definitions. Magnitude, which we already defined in an earlier lesson, is the amount or size of a number. And as you might recall, it is always positive. The order of magnitude, which is part of what we're going to be using here today, is the exponent n of a number written in the form a times 10 to the nth power, or scientific notation. Okay, so let's take a look at a couple of examples. Example 1. Among the galaxies closest to Earth, M82 is about 1.15 times 10 to the 7th light years away, and Leo 1 dwarf is 8.2 times 10 to the 5th light years away. Which one is closer? Okay, now, to determine which number is larger, what are we going to look at? We're going to look at their exponents, because they're both written in proper scientific notation. Since the exponent 7 is greater than the exponent 5, we know that 1.15 times 10 to the 7th is the larger number. Well, since we want to know which one is closer, it's Leo 1 dwarf, because the closer is the smaller of the two. Okay? So one way to figure out the magnitude of two numbers, or the order of magnitude, is to simply compare what their exponents are. Now, another way that we can do this is to convert them both with the same power of 10. Okay? So, going back to our example, we had Earth, M82 was closest to Earth by 1.15 times 10 to the 7th, while Leo 1 dwarf was 8.2 times 10 to the 5th. Well, one other strategy is to compare both of these numbers with having the same exponent. So let's say I wanted to rewrite the first number with a exponent of 5. Well, if I'm going to make that exponent smaller by 2, I have to make this decimal part larger by 2, so that would be its equivalent. So when we compare the non-exponential portion, we see that 115 is obviously greater than 8.2, and so that we know that 1.15 times 10 to the 7th is the larger of the two numbers. Okay? This is clearly a little bit more involved way of doing it, but it's getting you to see that if the exponents are the same, then all you care about is the decimal portion. And like anything, the more ways you understand how to do something, the better off things are. Example 2. The subatomic particle pion has an average life of so many seconds, while the particle muon has an average life of so many seconds. Which one has a longer life? If I'm talking about longer, I'm talking about larger. They have different exponents. One has the exponent of -6, the other has the exponent of -8. Which of those two is the larger number? -6 is larger. So then that means 2.197 times 10 to the -6 is larger than 2.603 times 10 to the -8. I don't care about the decimal parts because the exponents are different. So muon has a longer average lifetime. Remember, the key thing that students have to be careful about here is you will understand which number is larger or smaller than the other. You have to make sure you are properly reading the question that you are asked. So let's look at the next 4 examples. Formax dwarf galaxy is so far away from Earth, while Andromeda 1 is so far away. Which one is closer? To be closer, it's got to be smaller. What is smaller? 5 is smaller than 6, so that means the Formax dwarf galaxy is closer. Okay? I don't care about the 4.6 and the 2.43. Next, average lifetime of the tau lepton compared to the average lifetime of the neutral pion, which has a longer average lifetime. Which number is larger? Since negative 13 is greater than negative 17, the tau lepton has a longer average lifetime. Now, let's take a look at two other examples. The questions are very simple. Which one is greater? Well, the exponents are the same. So now what I'm doing is comparing 1.815 to 1.82. One student's suggestion is the ones are the same, the eights are the same. I'm comparing 1 to 2, 2 is greater. That's how I figure it out. I don't look at its 3 digits and 2 digits. Another suggestion is rewrite the numbers after the decimal with the same number of digits. 820 is clearly bigger than 815. And then the final, which one is lesser? Same exponent. Doesn't do me any good. 4.34 compared to 4.335. The 4s are the same. The 3s are the same. 4 is greater than 3. So which one is the lesser of the two? 4.34. So all we did today is to figure out, I'm sorry, I apologize. Which one is so hopefully everybody's jumping up and down right now, yelling, wait a second, you said 4.34 is greater, so then which one is lesser? This one here. Sorry for that. So the point today, we did not do anything different in terms of our work on scientific notation in that. All we did was compare numbers that were in scientific notation, to figure out which one is larger or smaller than the other.